All right, so you should have already tried questions 1, 2, and 3. And now you can watch the video to see if you did them right. So question number 1. Here's how I do it. There is 100 degrees Celsius times 1 kilogram of it plus 20 degrees Celsius, and there's 2 kilograms of it. And then we divide it by 3 kilograms in total. So on the top, we get 140 divided by 3, and we get whatever 140 divided by 3 is. 46.7. Now, if you notice, I haven't been doing significant figures for this. We will get into significant figures a little bit more later on. But there's some problems in the work here to why we don't have significant figures. Number 2, 0.10 kilogram of an unknown metal at 94 degrees Celsius placed in 100 grams. We need everything in kilograms, so we change this to 0.1 kilograms of water at 10 degrees Celsius. The final temperature of both are 17. What is the heat capacity of water? So I'm going to draw it out. Here's my container. I've got some water. I list everything I know for the water. Mass is equal to 0.1 kilograms. Change in temperature for the water is equal to plus 7 degrees Celsius. Specific heat capacity for the water is 4.18 kilojoules per kilogram degrees Celsius. Then I've got my piece of metal that I don't know what it is. I know my mass of that metal is equal to 0.10 kilograms. I know my change in temperature for that metal is equal to, it started at 94 and it dropped down to 17. So we do 17 take away 94. Final temperature minus initial temperature, negative 77 degrees Celsius. And my C is equal to I don't know. So the amount of energy gained by the water is equal to the amount of energy lost by the metal. So I have to figure out the amount of energy gained by the water. Q equals mc delta T. Q equals 0.1 times 4.18 times 7. Q equals, just do that on my calculator, 2.926. And that's going to be a positive kilojoules. So now we know the quantity of heat lost by the metal. Metal. Q equals mc delta T. We use negative 2.926 is equal to 0.1 times C times negative 77. And this becomes negative 2.926 is equal to negative 7.7 times C. Divide both sides by negative 7.7. And C is equal to 0.38 kilojoules per kilogram degrees Celsius. I can go here and I can look for 0.38, and that could be brass or bronze. Brass or bronze, it looks like. Right here, brass and bronze. Concrete is pretty close, but concrete is not metal. I think copper is pretty close as well. No, copper is the close one. Concrete is 0.88, so copper is close, but it's most likely brass or bronze. All right, so let's look at question number 3. A piece of copper at 90 degrees Celsius is added to 0.2 kilograms of water at 15 degrees Celsius inside an aluminum calorimeter that has a mass of 0.1 kilograms. The final temperature of everything is 25 degrees. What is the mass of the copper piece? Let's draw it out. Got a little bit more room here. So there's my calorimeter. There's my water. And I've got my piece of metal, piece of copper, that is dropping into the water. So what do we know about my metal? About the copper? Do we know the mass? No, we don't know the mass. We're going to have to calculate the mass. Do we know the C for copper? Yeah, it's 0.39 kilojoules per kilogram degrees Celsius. Do we know the change in temperature for the copper? You bet we do. The change in temperature started at 90, ended up at 25. That's a negative 65 degrees Celsius temperature change. That's the copper. Oh, you can't see that. Sorry. The calorimeter. We know the mass of the calorimeter is 0.1 kilograms. We know the C because it's aluminum, 0.90 kilograms. We know the change in temperature is equal to, what, 15 to 25 is 10 degrees Celsius. Lastly, we've got the water. We know the mass of the water, 0.2 kilograms. We know the C of the water, 4.18 kilojoules per kilogram degree Celsius. The change in temperature for the water is equal to 10. So, the copper object lost a bunch of heat. These guys gained heat. So we have to figure out how much these two guys gained, add it together, and then that's how much the copper lost. So let's deal with the water. Q equals mc delta T. Q equals 0.2 4.18 times 10. So 0.2 times 4.18 times 10. 8.36 kilojoules. That's how much the water gained. Now let's do the calorimeter. It also gained. Q equals mc delta T. Q equals 0.1 times 0.9 times 10. Q is equal to 0.9 kilojoules. Now let's figure out the total. We just add these two numbers to get 9.26 kilojoules. That's the total amount gained. Now, since the water in the calorimeter gained 9.26 kilojoules of energy, the copper must have lost 9.26 kilojoules of energy. So now let's go and we'll deal with the copper. Q equals mc delta T. Copper lost 9.26 kilojoules. It has a mass. We don't know the mass. It has a C of 0.39, and it has a temperature change of negative 65. We multiply these two numbers together. 0.39 times 65 negative equals negative 25.35. Now to isolate our mass, we divide both sides by negative 25.35. Now we just do that. Divided by negative 25.35. 0.365. So 0.37. So the mass of the copper is equal to 0.365 kilograms. That's what we were looking for. All right, so it's a lot of formulas. None of the math is hard. It's just a matter of knowing that something's losing heat and something's gaining heat. The amount of heat that is lost is equal to the amount of heat gained. All right, so we'll talk about these questions next time. And yeah, thank you for watching.